Aloha, everybody. Welcome to the Know Your Ocean Speaker Series for August. Thank you for being here with us tonight. My name is Sarah, and tonight we are joined by Liz Yannell, the program manager of Hui o Wai Ola. She also has a few special guests, but I'll let her introduce them as well. Tonight, Liz will be sharing findings from the Hui report, which comes out every 2 years. And this report outlines the ocean water quality findings and conditions along a 40-mile stretch of Maui's leeward coast. And tonight she'll also be sharing any notable trends and patterns that have been indicated by monitoring coastal water quality in key areas around the island. So tonight's presentation is a part of our Know Your Ocean Speaker Series. It's once a month, usually on the first Wednesday of every month at 5:30 p.m. We also want to mahalo the County of Maui for being one of our partners and being able to put this presentation on for you tonight. And as a quick side note, if you enjoyed tonight's talk and you'd like to see more of them, we do have a once a month newsletter that goes out from MNMRC, and it lets you know all of the details, the registration links. Sometimes we even have these talks live and in person like we did last month. So if you want to stay updated, the link will be in the chat later on for you to go ahead and sign up for Reef and Brief, our monthly newsletter. Yeah. And if it's your first time being on one of our talks, welcome. We are the Maui Nui Marine Resource Council, and we are a 501c3 nonprofit working for clean ocean water, healthy reefs, and abundant native fish. We've been doing this since 2007, and we believe that healthy coral reefs mean healthy communities. And so all of us living on this island, we're all connected. And so our efforts to help protect the reefs really take a Mauka to Makai approach, working on land and in the water to have that full continuity, and knowing that so much of what affects our oceans and our marine life really does start on land. So our work takes a lot of different forms, and some of that means one of the biggest things, obviously, like we are showing you tonight, is testing water quality at over 39 locations around the island. That's Hui o Wai Ola, whom we have tonight. We regularly monitor local fish and reef populations. And our most recent program is our reef-friendly landscaping program, in which we not only teach professionals, property managers, agricultural businesses how to use natural alternatives, but we can also help certify professionals and entire properties once they have gone through the course. So that's a lot of things that we do. And we're also, on that note, we're excited to share that we've already had one class of our Reef-Friendly Landscaping program completed, and we are going to open it up again starting on September 4th. This will be a little different. It's completely online. So the last class was a hybrid in-person online format. This will now be 100% online. It will be self-paced, but it will be taking place from September 4th through October 10th. That's the window in which all of our students will have time to complete the sessions. And this is a great opportunity for people. We had people ask us from outer islands, if this would be available online somehow. So if people are not here in person, or they're just not able to make an in-person type of class, this is really a perfect opportunity to still learn how to transition to natural land care practices. So the link to sign up will also be in the chat, and enrollment will be open up until September 3rd, the day right before it starts. So if you or somebody you know, or perhaps the service provider at your HOA, if you're interested in having them provide this service, please feel free to send them the link. We also want to invite you guys. We love a good hang. And so tomorrow, Ocean Vodka Farms and Distilleries is hosting a farm raiser for us on their farm, where they will donate 10% of every purchase. That we have a little digital flyer that we'll be sending out, and we'll have at the farm. If you show this to the server, they'll donate 10% of your purchase to us. So I will be there. Amy will be there. Come, and we'll have a little table. Like, come stop on by from 4 to 7 p.m. tomorrow. Just come talk story. We have little koozies actually that will also be with us at the event. So we'd love to see you guys, and it's for a good cause. They'll donate 10% of your purchase to us. So if you feel like starting, it's a 3-day weekend for some people. So if you have one of those and you feel like coming to hang out, we would love to see you guys. Okay, and then just a few notes before we introduce our speakers. We will, as per usual, leave time at the end of the presentation to answer your questions. So please submit them using the Q&A little function at the bottom of your screen, or if you're joining us on Facebook, like feel free to just drop a comment there, and then those will be relayed to me. And we'll get through as many as we can, time permitting. And yeah, and this is being recorded, so this will be uploaded to our YouTube channel in a few days. And of course, this is live streaming to Facebook as we speak. So if you miss anything, or you got to leave early, or you just want to share it with a friend, those recordings will be available for you shortly after we end tonight. Okay, and now for our speaker. So Liz Yannell joined the HOKWO in 2022, and she became the program manager just last year in 2023. She has a bachelor's degree in environmental studies from Florida Gulf Coast University. And in 2022, she graduated from the Marine Options Program at Maui, while also working as the assistant in the Marine Lab on campus. As the program manager, Liz is responsible for a lot of things. She coordinates field, lab, and logistical support, fellow team leads. She manages the volunteer program. She also oversees the monitoring operations and data collection, data entry, and record keeping. Data is very important. And meeting with the advisory, technical, and steering committees to ensure the successful continuity and growth of the program. She also often joins volunteers in the collection and analysis of coastal water samples in the field. I can attest to this. I got to join them one day. It was awesome. Liz and the team, they're amazing. Can't say enough good things about them. And Liz is from Oahu, and she currently lives in Kula with her 2 kids and husband. She loves all things ocean related and is very passionate about coral reef conservation. And we're so glad that she is, because we have her with us tonight. So Liz, Kim, Tova, thank you so much for being with us tonight, and the floor is yours.
Thank you, Sarah. That was such a sweet introduction. I'm going to share my screen. All right. I think we've got it. I think we're up. Okay. Aloha mai kako. Hello, everyone. My name is Liz Yannell, and I am the program manager at Wai Ola. Thank you all for joining tonight. We will also be joined for our Q&A section by Dr. Kim Polinsky, who is the technical advisor with us at Wai Ola. And she's also works at the Nature Conservancy as a staff scientist since 2015. And additionally, we have Tova Calendar from our Hui o Kawaiʻola steering committee. And she's also the coordinator for the West Maui Ridge to Reef Initiative. So I have a lot I'm wanting to share with you tonight. So we are going to begin. The outline of tonight will be an overview about who we are. Some of you know us, some of you don't. We'll talk about our findings, the trends we're seeing, what's new, our Lāna'i data, our Lāhainā data before and after the wildfires, and the turbidity and nutrient trends that we're seeing in North Kīhei. We'll also talk about what we do with our data and where it goes and ways that you can help. And then, of course, time at the end for questions and answers. So the importance of coral reefs, they are the best. They are culturally, economically, and ecologically vital to our island of Maui, to the people of Hawaiʻi, and the way that our islands are all connected. And with the group we have tonight, I doubt it's news to any of you that our coral reefs are being challenged by global stressors as well as local stressors. And that is why our work is so important. Our water quality work has the focus of coral reef ecosystem health. And while it's difficult to address and reduce impacts from global stressors like climate change, ocean acidification, for example, it's possible to focus on local and more controllable stressors that are impacting our local coastal water quality. So measuring the coastal waters helps us to understand the dynamics of an area so that we can better protect our reef ecosystems from harm and improve their resiliency over these stressors that we know about. And who we are, a little bit about who we are. We are the first citizen science-based water quality monitoring program of its kind in Hawaii. And we are a coalition made up of different partners that care about the quality of our ocean waters. And those partners include, you can see at the bottom, the Maui Nui Marine Resource Council that are hosting us tonight, the Nature Conservancy, and the West Maui Ridge to Reef Initiative. And you can see in the middle photo, that's Kim Flinsky that you'll get to meet a little bit later, and Emily Fielding from the Nature Conservancy, our partner, meeting with the Department of Health and having our QAPP signed and approved by the Department of Health. So what that means, our QAPP is our Quality Assurance Project Plan, and that sets our group apart. It's this very long document that details all the ways that we ensure that our data is quality assured, it's consistent, it's accurate, and it's up to the level of the standards that the Department of Health work at. And so we're very proud of that. And the reason that Hui o ka Wai Ola wanted to be a quality assured program is because we wanted our data to be actionable, to inform policy and inform action. Without a QAPP, our data could easily be ignored, but because of our quality assured program, we have a strong footing and a strong, firm standing in the data that we collect. And we are able to share it with good confidence. And we're very proud that we're able to bring in cutting edge science with our citizen science volunteers and bring that together in the community. It's a really wonderful way to connect in that way. So our volunteers really are one of my favorite parts of our program. We really have such wonderful people that join us and show up regularly to help us collect our samples, analyze our data, and manage our data. We currently have about 30 volunteers that are the heart of our program, and the program absolutely wouldn't be the same without them. And we also have a very small staff, a handful of people that help us with sampling, coordinating, and lab work. And that staff, we work in addition to the key partners that help to drive our coalition for success. And since our program began, we've taken over 4,300 samples, which is a lot of data points to look at and try to share with you tonight. So Hui o ka Wai Ola means the Association of the Living Waters. And together we work towards our mission to deepen the understanding of Maui's coastal water quality through science and advocacy to accelerate positive change. And a little more about who we are. Last July, our South Maui sampling team hit the 100th sampling week, and we gathered to celebrate outside of our South Maui lab at the Hawaiian Islands National Marine Humpback Whale Sanctuary. Sorry, that's a mouthful. And we were joined by House Representative Therese Amato and Senator Angus McKelvey that were so kind to join us and deliver in person this award of recognition for the work that we do. And it was signed by the two of them and also signed by the Speaker of the House, the President of the Senate, the House Chief Clerk, and the Senate Chief Clerk. And we also were joined by County Council Member Tom Cook and a representative from the Mayor's office, as well as our wonderful supporters and many of our volunteers and partners. And we all came together and ate donuts and celebrated and took our celebratory 100th sample week sample. And we're very proud of that event. It felt really good to us to reach that achievement. So what we do, we test for 12 parameters, and we currently have 39 sites all along the leeward coast of Maui. So I think you can see my cursor. That is Honolua Bay Marine Reserve up at this top purple dot in the top northwest. And then we go all the way down the leeward coast to this bottom green dot, which is Ahi'ikina'u Natural Area Reserve in the south. And since 2016, we've collected samples at 52 different sites, but we currently have 39. And all of our data is made publicly available. So I'm excited to say that hot off the press, we just released our newest coastal water quality report. And if you don't geek out over massive Excel sheets of data with, thousands of data points, you can download this report. Our team did truly an incredible job highlighting some of our most important and our most interesting findings into a format that's much easier to digest. And tonight I selected some pieces from there, as well as some of our newest information to talk about and share with you. But I encourage you to download our report and occasionally check back in with our website when you want to refer to the report, because we are going to be updating it with new versions as we go along until, of course, we reach 2026 and we're ready to publish a new report. So what we test for, as I mentioned, we have 12 water quality parameters, including both physical and chemical parameters. So our physical parameters include, well, I should back up a bit. Okay, so we have teams of 3 to 4 people that sample a handful of sites every 3 weeks, walking into knee-deep water and collecting samples. And then those samples are taken, the physical parameters are tested that same day, same morning. We take the samples to our mobile lab, which is in the back of someone's vehicle, and we test for these 3 things, or I mean, these 5 things. And the interesting thing of our schedule, sampling every 3 weeks, gives us an unbiased collection of water quality conditions at each site, and allowing us to see variation in how our water's doing and is affected by things like seasons and moon cycles and tide cycles and high surf and king tides and rain events and you name it. And so with these physical parameters that we immediately test, we look at pH, which is the measure of acidity in our ocean samples, dissolved oxygen, which tells us how much oxygen is dissolved in the water and readily available to support aquatic life. Temperature, of course, allows us to track variations in temperature at a site year over year, or compare temperatures between sites and identify when an area might be in danger of a bleaching event. And then salinity, shifts in salinity of our samples can vary near the coast due to factors like tides or evaporation or volume of fresh water input from heavy rainfall, release of groundwater, or a nearby flowing stream. And then lastly, turbidity refers to the clarity of the water. And to show a little more about turbidity and what it is, turbidity is caused by particles suspended or dissolved in water that scatter light, making the water look cloudy or murky. And just to give you an idea of how turbidity affects visibility when you're in the water, these are some photos that Bill and Dana Reed and Bill Rathfin took at Kapalua Bay when they were snorkeling. And so on the left, you can see they're snorkeling at a turbidity of 1.14. And then on the right, it's clearer water. The turbidity is 0.31. And so the top photos are the same distance. The bottom photos are the same distance. And you can see how just less than 1 NTU, which we'll talk about that a little later, how much that changes your visibility, how much harder it is to see your friend when you're snorkeling above 1 NTU of turbidity. So, at that distance on the top left photo, is that my friend? Is that a shark? It's something really to think of when you're in the water. We want to see our coastal waters with clearer water that we're able to snorkel in. They make the corals happy as well. So high turbidity is driven by stream input and coastal erosion usually, or resuspension of the sediment that's already in the water from either of those sources. And of course, it can also be a combination of all of those drivers. And when we find high turbidity or a brown water event, for example, it often indicates that there are issues MALCA within the watershed. And it's important for us to know and understand the cause of high turbidity at sites so that we can appropriately address them and find actionable solutions. So our other parameters, we spoke about our physical ones, and then these are our chemical parameters, including nitrates, ammonia, total nitrogen, phosphate, and total PEEF, total phosphorus, and silicate. And understanding the organic and inorganic nutrients in our water helps us to pinpoint upslope areas that need to be addressed. So I think of our chemical parameters as indicators that help us understand the ocean chemistry story of a site. Unlike turbidity, sources of nutrients can be a little harder to trace, but a couple examples include high levels of nitrates would point us to wastewater or agricultural influences, whereas silicates are a pretty clear groundwater indicator, showing that groundwater has entered in the coastal waters. And as I mentioned before, our program is based off of the protocols and the parameters established by the Department of Health Clean Water Branch. So I've talked about what we do test for, but I think I should also mention the things that we don't test for. So we don't test for bacteria, pharmaceuticals, pesticides. We don't test for personal care products or other chemicals of concern, but we do definitely pay attention when other scientists and other people are studying those things. So more about nutrients. There are natural sources of nutrients that we find in our ocean and in which ocean life depend on. But when nutrient levels are found in excess near shore on Maui, they're mainly driven by wastewater and agricultural practices. So in which excess nutrients will enter our groundwater through the porous volcanic makeup of our island, and then over time seep out into the ocean floor through springs in the ocean floor. And similar to turbidity, there are many cases in which signatures of both agricultural and wastewater derived nutrients are present at one site. But when nutrients are in excess, they encourage an overgrowth of algae or seaweed in the ocean, and also increase corals' susceptibility to diseases and weaken the coral reef structure. And you can see this photo on the left is a hookweed bloom. That's an invasive species washing up on the shore at Kuau Bay. That's quite a bloom. And then the top right is turf algae taking over the reef structure and competing with the coral for space on the reef structure, kind of smothering it out. And then on the bottom right, you can see treated wastewater effluent seen entering the ocean water by seeps at Kahekili Beach, shown by the little bubbles that you can see in that picture. And the bubbles are that effluent surfacing through the reef. Okay, to talk about our general trends of West Maui. So the primary issue in West Maui is high turbidity or low water clarity. So we'll talk about that. We'll show some graphs a little later, but high nutrient levels are the secondary issue. But this photo here is a picture of extremely high turbidity with lots of sediment, suspended particles floating around. And when an area gets high, when turbidity gets so high in an area like this, it can smother the corals by reducing or eliminating their access to light, which the corals depend on for survival. And high levels of turbidity also can make it a lot harder for juvenile corals to settle on the reef structure and create new reef structure. So in West Maui, all 22 of our current sites exceed the state standard for turbidity, which is set at 0.20 NTU. So yeah, all of the sites that we monitor are just above that mark. And then in South Maui has two issues. So we have high nutrient levels and now also high turbidity levels as our two major issues in South Maui. So all 17 of our sites that we test in South Maui exceed at least one state standard for nutrients and also exceed the state standard for turbidity. Okay, so here we have a graph illustrating the geomean of turbidity or water clarity at all of our leeward sites from 2016 to 2023, going from Honolulu Bay Marine Reserve in the north all the way to Ahi'ikina'u Natural Area Reserve in the south. So first, I would like to point out the range. So we're going from 0 up to about 13 NTU. And NTU stands for nephelometric turbidity units, which is just the measurement of how we talk about how high or low turbidity is at a site. And the red dashed line with this red arrow, so this is the state standard set by the Department of Health at 0.20 NTU, which is the clarity we would like to see in our coastal waters. So to explain a little bit more, a geomean, which I'm talking about, this is an average that indicates a central tendency. And using geomeans is consistent with the Department of Health protocol, and they're useful to us because our goal is to characterize generally what a site is like over time. So geomeans are useful because they don't skew trend lines when there are outliers within our data. And I also want to point out that with these geomeans, they're generally representing hundreds of data points. So these are all of the 50 sites that we've collected from, some since 2016, some are newly established, and some of them have been paused and are not active. But we have at least 2 years of data on all the sites on this graph, except for our new sites that we established in the burn zone, which we'll talk about a little later too. Yeah, occasionally we have to drop or add sites depending on funding and issues that we're seeing in the water. But what you don't see on this graph are 2 sites on Lāna'i, which I'll also talk about a little later. So this is just like our Maui bar graph. So the biggest takeaway I'll say with turbidity that we talked about with our data this year is that in general, we've noticed that reefs generally cannot sustain turbidity with a geomean greater than 5 NTU for an extended period of time. So it's one thing when sediment flushes in and into a site and the turbidity goes up really high, but then circulates out. And then it's another thing when the turbidity becomes chronic and it's chronically at 5 NTU or higher. And when that happens, we often see this correlation of degraded or dead reefs out from our sample site with that high turbidity. So of course, every microzone is different, and we are continuing to understand the resiliency of certain reefs and certain coral species. But sadly, with the 50 sites that we've monitored, we have 14 sites right now that have this concerning above 5 NTU geomean, which means that 28% of our reefs from the sites that we sample at Leeward Maui are struggling, degraded, or already dead. I'm going to put this line here just to show the difference, like the marker. So to the left of the blue line is West Maui, our West Maui sites, and to the right are South Maui sites. So I can't highlight all the trends and hotspots that we're seeing, but I will say that you can see high turbidity is definitely an issue across most of West Maui, but it's also high from South Maui, starting at Ma'alaya condos and going basically until we reach Wailea at our 2 Keawekapu beaches, Kilohana Drive, which is the North Keawekapu site, and then Keawekapu Beach, which is down at the end. And then it continues to be pretty low, our turbidity, as it keeps going south. So I thought I would just point out our top 3 sites with the clearest, lowest turbidity across all of our current sites. Number 1 is Keawekapu Beach in Wailea. So here we go, Keawekapu Beach. It has an NTU geomean of 0.78. And then our second cleanest site is Oneloa Beach, and that is also known as Ironwood sometimes, and that's between Honolulu and Kapalua, and it has a geomean of 0.79. Then we have back to Wailea, Kilohana Drive is our third cleanest site, and again, that's a Keawekapu Beach, and that's at 1.04 NTUs. And so our highest turbidity across all of our current sites, I think you can probably figure out which one is the highest turbidity site we have. That is Waipuilani. So the geomean here is 12.5 NTU, which is higher than any other leeward site that we test at. Waipuilani has stormwater input from either side of our sample site, and it has some poor circulation. There's also some evidence of coastal erosion, but we are trying to keep an eye here and trying to determine exactly why turbidity at this site is so exceptionally high. Our second current site with the highest turbidity is Ka'opala Bay in Kahana, and that's at 8.3 NTU. That site's also dealing with coastal erosion as well as poor circulation. And then we have our third highest is Ukumehame Beach. And the NTU is 8.2. And that site is also dealing with coastal erosion and sediment input from adjacent streams and gulches. So these are our concerns and why we continue to sample. It's our call to action. We can come together on our island and prioritize our watershed systems and the health of our ocean ecosystems, but it's something that we have to do together. Okay, to talk about nutrients. So this is our geometric mean for our sites, again, our 50 sites in Maui. And it's the geometric mean for nitrate, nitrite, and nitrogen, which we just call nitrates. And the range is from 0 to 300, about 350 micrograms of nutrients per liter of sample. So the Department of Health standard is set at 3.5 micrograms per liter. So you can see that nitrates in West Maui aren't as much of an issue as they are in South Maui right now. But we do have sites like Kapalua Bay and Ka'opala and Pohaku and Hanaka'o'o or Canoe Beach that really are exceeding that standard. And then in South Maui, they are high from Ma'alaya condos and then continue to be pretty high going south until basically we get to Wailea. With Ulua Beach Park and Maluaka kind of catching our eye a little bit, and even Ahi'ikina'u South having nutrient levels higher than we would expect for the natural area reserve. And looking at this graph, I'd also just like to highlight our star of South Maui, which is the beach at Kealia Pond. So that beautiful wetland system really does help to filter and absorb nitrates from entering into the coastal waters. And it's really evident when you look at the nitrate levels across all of North Kīhei and then look at that one site. So yeah, we love our wetlands, we really do. So the three sites with the highest nitrate levels that we currently monitor, again, it is so easy to see. Cove Park, it is coming in at 343 micrograms per liter with the geomean. So that's 100 times higher than the standard set by the state for nitrates. And it's more than 2 times higher than any other site that we sample at or have ever tested at. Multiple studies are showing that there's a wastewater influence from the Kīhei wastewater reclamation facility that is likely a driver for elevated nitrates near Cove Park. And we're also thinking that there must be an influence from coastal cesspools and septic systems. So this is one of our top priority sites, and we do need to see change here. Second highest nitrate levels that we see are at Ma'alaya condos. So that comes in with a geomean at 134 micrograms per liter. And then our third one is Pohaku or S-turns on the west side, just north of Ka'anapali. And it has a geomean of 131 micrograms per liter. And our sites with the lowest nitrate input in all of leeward Maui, the first one is Papalauapali. So that is the last beach you can park at if you're driving south before you hit the Pali. Yeah, it comes in below the state standard, 2.31 micrograms per liter. So that's a beautiful thing to see. Our second lowest nutrient site is Ukumehame. Here we are. It's a popular surf spot, sometimes known as Thousand Peaks. It also comes in below the state standard, so 2.75 micrograms per liter. And I'd like to just say that this stretch, Olawalu to the Pali, We like to call it a bright spot in the stretch of Maui because it is, since we've been testing, pretty consistently low in nutrients, and there's this incredible mother reef that's outside, out from the shore of our sample site. And if you remember in the last slide, I was pointing out that Ukumehame does have high turbidity right now, but we're happy to see that the nutrient levels are so low. We definitely are keeping an eye on that area. So last one that has such low nitrates is Lahaina Harbor. So that's one of our newest sites, and we don't have data from before this past year, so we don't know what it was like before those devastating fires. But we do know that nitrate values have been low for this entire year, and the harbor doesn't have freshwater input that flows right in or anything like that. And the geomean is 3.02 micrograms per liter, which comes in below the state standards, which I'm pointing out for open coastal waters, but because it's a harbor, it actually has higher, a different set of standards, and the nitrate standards that are set for harbors is 8.0 micrograms per liter. So it's coming well below that threshold mark. Okay, so what's new with Hui o ka Wai Ola? Since May 2023, we've added in 12 new sites. And we've also started we did a Lāna'i sampling project, and we partnered to collect samples for other organizations and researchers in the immediate days after the fires. And we established our stormtrooper team to go out after heavy rains in the burn zone. And we also started this new quarterly multi-increment sampling along the burn zone from a kayak in contract with the Department of Health to test for metals and sediment. And we've also seen turbidity trends increasing in North Kīhei and nitrate levels declining in North Kīhei. So to speak first about Lāna'i, so County Council member Gabe Johnson approached our team because he had an interest in collecting coastal water quality data on his home island of Lāna'i, and community members on Lāna'i had concerns about the coastal water and they wanted a more easy to find public data about water quality in their nearshore waters. So we began testing in June 2023, but for logistical reasons after the August wildfires, we couldn't continue sampling past our 1-year contract, and we ended the project in May 2024. But in the 1 year of sampling, we established that, we established one Lāna'i resident volunteer that would meet us every 3 weeks, and we collected over a dozen data sessions. And the bottom line is that Lāna'i sites, at least these two that we sampled at, don't have the same turbidity issues to the level that we see on Maui. So the top photo on the right is of Hulapo'e Bay, and the color of that water to me is the definition of paradise. It's so beautiful. It is so clear. Even when there's a big rain event and there was flooding in the parking lot that's adjacent to Hulapo'e Bay, turbidity still remained relatively low. And then the bottom photo is sampling at the harbor, Manele Harbor. And yeah, when you look at the graph, Hulapo'e Bay came in below 1. So that's pretty great. Those are some of our clearest sites on Maui. And Manele Harbor, it does come in higher than the state standard set for harbor waters, but I will just say that we were sampling next to the boat ramp, which is kind of like the armpit of the harbor. It probably has some of the worst circulation within the harbor, and I think that if we were sampling closer to the harbor entrance, we would have seen lower numbers of turbidity. Talking about nitrates, so yeah, Hulapo'e came in below the threshold. We're happy to see that. And then yeah, the harbor came in so low below the threshold. I don't even have the threshold marked on this graph. So the threshold for harbor waters is 8.0 micrograms per liter, and Manele Bay is coming in below 6. And for reference, Ma'alaya Harbor, the geomean is 52 micrograms per liter. So yeah, we're seeing a lot less nitrates on Lāna'i than we do in Maui. And before I move on, I want to just make a really quick shout out to people that helped us continue to be able to do this project for the full year that we did. Yeah, there were a lot of logistical challenges after the devastating fires. You know, the ferry, it was complicated, but I want to make a shout out to Trilogy. They helped us be able to continue our sampling. Also, Stanley Ruidis and Councilmember Gabe Johnson and his team, and Mike Oxner. We couldn't have completed the project without them. And another shout out to the Lāna'i High School STEM students and the STEM teacher, Nick Brilliande, that are working to take over the project that we can't continue. They're taking over beach sampling on their island. So we met with Nick and his awesome students for a field trip down at Hula Po'e on our last sampling day in May, and showed them how we collect and test our samples. So yeah, that's exciting that they're taking the torch. And yeah, look out for these up and coming teenage scientists on Lāna'i. And then the last thing I'll just say to any of the Lāna'i residents or people that care about Lāna'i and their water quality data, there is an extensive data set collected by the Marine Research Consultants Incorporated for Pulama Lāna'i. And we're trying to help get more awareness about their publicly available data. They sample in the same 2 sites that we do according to EPA standards, and even do more than we do by also conducting reef surveys. So yeah, and it's I think quarterly published, so you can still find data about these 2 beaches. Okay, before talking about any data in Lahaina, I just want to take a moment to pause and hold space for how devastating August 8th was and the wildfires were for our island and our community. Sampling in the burn zone and sharing our findings from the data we've collected, we feel is an important way that we can serve and support our community as our Lahaina friends and family continue to heal and make plans for their future. I'll say that our West Maui sites didn't take any pause on sampling after the fires, except for the sites that we that are in the burn zone. So that was an incredible achievement of teamwork from our group. And we did it because we knew that this data would be important, especially to capture the long-term trends over time. And thankfully, with the help from the Department of Aquatic Resources, driving us out into the burn zone in their official truck, we were able to have boots on the ground and begin our sampling in the burn zone at the end of August, just 3 weeks after the fires. And DAR was kind enough to take us out each week for 5 weeks in a row to try to establish a baseline for our new sites. So, and then we picked up our normal every 3-week rhythm in October, and eventually got our own permits to enter the burn zone. But we do have 3 sites that I'll just point them all out. So we have 505 Front Street, Kauaʻula Road, and Polanui, Uhaʻilio. And these were our 3 sites that we started sampling at the beginning of 2016, 2017. And, oops, sorry, I didn't mean to, okay. And then we have 4 sites that we quickly added in. Mala Tavern, there's an important storm drain we wanted to monitor. Kahoma Mala Ramp, which is right next to the outflow of Kahoma Stream, which is important for us to watch. And Papalawa Street, there's a storm drain there, and that is right across from where the outlet mall was. And then Lahaina Harbor. All right, so talking more about Lahaina. So our data has remained in the normal ranges across all of the parameters that we test for with our normal ocean water chemistry parameters. There are no red flags, and it is a big sigh of relief. And we also supported other scientists, especially in the immediate weeks and months after the fires. Early on, we were able to collect heavy metal samples for the UH Manoa research team, VOC and SVOC, so that's volatile organic compounds and semi-volatile organic compounds, samples for UH Water Resources and Research Center, as well as Enterococcus bacteria samples for Surfrider. And these partners didn't find any concerning levels in their research for ocean recreation uses or ecosystem health. And in April 2024, the Department of Health, gathering together complementary data, confirmed that coastal waters are safe for recreational users. And if you would like to read more about that and their updates as time goes on, that is the link to the Department of Health portal. And of course, important research will continue in Lahaina. Over time, partners are testing for metals in the ocean and in sediment and in fish, because we certainly don't have all the answers after the 1-year mark. And we have also begun a new contract with the Department of Health to do quarterly kayak testing for metals and sediment along the burn zone and a control site from a kayak. And this is different for us because we're regularly testing metals now with this contract, and it's a multi-increment sampling with collected from a DU or a decision unit. And we're focusing on areas where the surf breaks and there's resuspension. So yeah, that's different than our normal knee-deep grab samples. Okay, to share a little bit of, this is a time series at 505 Front Street, so one of our sites that we've been collecting at since 2017. So these are actual data points over time, and then the blue line is our trend line, and you can see how it remains pretty consistent with turbidity at 505 Front Street. We, of course, saw some spikes of turbidity, which we were expecting, but the trend line remains pretty consistent. And then nitrates at the same site. You can see in this time series, again, 2017 to April 2024. And this trend line, nothing crazy. This big spike here is from February of 2023, I'm sure after a big storm. And then we have our shark pit area site. And so another turbidity time series. And you can see, there were some big spikes of turbidity after the fires, but it also went back down and pretty much cleared out. So that trend line is remaining, again, pretty consistent. And then with nutrients at shark pit area, we're also seeing, interestingly, that nutrients are dropping and continuing to decline in this area. And this is just a photo I thought might be interesting to share, photos of the sample buckets that we collected at Lahaina Harbor. So you can see the first one on the left, August 30th, as I mentioned, was our first sample day. And you can see there's lots of ash in there. There's oil slicks on the side of the bucket. And less than a month later, it was cleared out a lot. And by the time we got to December and January, it was looking so much cleaner. January 9th was our first flush event, which many of us were really concerned about what would flow into the water from the burned zone. And you can see that so much was done. The harbor waters were looking pretty clear even the morning after the first flush. So again, these bar graphs are showing geomeans in Lahaina. We saw no red flags. We did see turbidity fluctuate, which was to be expected, but luckily tremendous work was done to clear the area and prevent ash from washing right into the ocean. And I think it was also very lucky that we had as much time as we did before that first flush event on January 9th. A lot of ash and debris were mitigated from flowing right in. And as I briefly mentioned before, we started our stormtroopers team. So that's us on the right, on our stormtrooper day. And so this is a team that's a little different from our normal team of monitoring, and we were watching for the first marker of 1 inch of rain hitting Lahaina, or a foot of rain flowing through Kahoma Stream, which is right next to Mala Ramp. And when we saw those markers, we would try to sample within 24 hours of that big rain event. So we've done 3 storm sampling so far this year, and we have funding to do 1 more as the wet season comes through again. And yeah, we were actually asked by the County Council Adept meeting to come and present our storm data right after that first flush event. So it's nice to be able to have this data to help guide management in the Lahaina area. So yeah, I thought I would also just throw out, we saw incredibly gorgeous and clear days in Lahaina as well, and we saw so much work done over time. On the left was a really clear day at the harbor, and then on the right was a sampling last week at Papalaua Street, which is, like, as I said before, right across from the outlet mall. And you can see behind where we're sampling that it's been cleared out in the back of the photo. And yeah, we also saw eagle rays, fish, turtles, so many crabs come back to the area over time. And these eagle rays swam right up as we were sampling at Mala Ramp, and I think brought us to tears. And we also saw this monk seal haul out at 505 Front Street on 3 or 4 different sampling days. And of course, we saw the humpback whales return. And you know, this journey ahead for our island and community is going to be a long one. But I feel like we are getting there, and that there is hope. Moving on, we're switching over to North Kīhei and what we're seeing in North Kīhei. So turbidity has recently gotten so much worse due to the trifecta of drought, fires, and ungulates, particularly axis deer, that have left the soil, Mauka, and in our gulches really loose. And then when we get those heavy rain systems, as you can see in each of these photos, the flooding and the amount of sediment that flush in have become a big problem. So this is our time series, our trend line showing Kīhei Canoe Club in North Kīhei. So you can see how much turbidity is increasing in North Kīhei alone. And these are actual data points over time. And notice how the high peaks, how much higher they are than they used to be. They're so much higher now. And the problem is that brown water, that sediment, is just staying and recirculating. And you can see at the time of our last report, which we published in 2022, we were looking at data from 2019, 2020, 2021, and turbidity was low, and we weren't seeing this issue. Same thing at Kalepo Park where our lab is. So yeah, turbidity is going up. These peaks are so much higher. And here's just another way to visualize our turbidity data in South Maui. So I'm going to point out the scale on the right, the key. You can see the purple and blue color is really low turbidity. And when we get to the brown color, it's really high turbidity for our geomeans. So you can see how this is going north to south, Ma'alaia Harbor to Ahikina'u. So you can see how, yeah, it's North Kīhei, it's brown, brown, brown. Then we get back to our South Maui and our Wailea sites, and it's so much more blue and clear. And we don't have our 2024 data published yet. We only started sampling at, or we unpaused our Wailea sites at the beginning of this year, so that's not in there. But as I mentioned before, they are clearer sites for turbidity. But what's interesting is that despite the increase in turbidity in North Kīhei, we're seeing a correlation of nitrates decreasing in North Kīhei now that the sugarcane production has ended in the Central Valley. So legacy nitrates from plantation agriculture that dominated the area's mid-elevation landscape continue to make their way to our coastal waters through the groundwater supply and entering out into the ocean with those elevated nitrates. And this contribution will continue to decline over time, as we saw when sugarcane ended in Lahaina. So you can see this trend line going down at Kīhei Canoe Club, which we're happy to see. So to share some dates, the Olawalo Sugar Company from Olawalo to Ukumehame was in production from 1981 to 1999, and it ended 25 years ago. And if you remember from our large nitrates graph of all of our leeward sites, the nitrate levels are really low over there, even below the state standard in the area. But I'm sure if we were testing back in the 90s and the early 2000s, we would have seen elevated nitrate levels, but now they have cleared out. Yeah, and then talking about North Kīhei, so HCNS sugar production in the Central Valley went from 1882 to 2016. So that's 134 years of sugar that ended 8 years ago. And we're starting to see it in our data. And I'm hopeful that in another 10 or 20 years, nutrients from legacy agriculture will have cleared out a lot, and hopefully our land is improved. And maybe we'll even have cesspool and wastewater facility upgrades so that this excessive nutrient issue won't be as big of a problem. Okay, we are wrapping up. So turning our data into action. So continuous monitoring allows us to capture trends. It allows us to identify hotspots, observe changes in water quality over time, and work with partners to identify actionable solutions. Our coalition partners at the West Maui Ridge to Reef Initiative, the Maui Nui Marine Resource Council, and the Nature Conservancy have used our data, as well as others, to support their research and guide them on where projects need to happen within the watershed. And they've done incredibly cool and important and hard work in the watershed to help our water quality below. We also work with partners, to identify actionable solutions at scale, and we present our data to support policy making. And we also love to support other scientists with their projects in ways that we can. So where our data goes, as I mentioned, the Hawaii Department of Health Clean Water Branch uses our data to supplement their water quality data, and they publish their integrated report every 2 years, and they use our data for that. And our data also has been used for NOAA, USGS, and other federal research studies, the Ocean Tipping Point Project, the Department of Aquatic Resources Water Quality Management Project for the entire state, and our Aqualink collaboration. So the photo on the right, we're excited about this collaboration with Aqualink. So they're tracking worldwide information about the oceans and temperatures and heat stress index for coral reefs on a live and easy to read platform. And they're incorporating our data, you can see here in the green box. And you can find this on our website under our current sites page and play around with it. It's pretty neat. You can click around to graph out specific sites or parameters and easily see our data that's published quarterly for them. And you can see that there's like the watch, warning, and alert. So turbidity at Honolulu is in the warning, and the nitrate levels is more in the watch. So yeah, it's a cool way that you can visualize our data in a different way. PAC-IOS also has a really a cool visualization tool with our data, and the EPA and Zenodo databases also publish our data. And then of course we make our data available to the public on our website. And we've received messages about our data being used in really meaningful ways, including like the Hulihia's current project gathering data for Lahaina restoration, providing a systems analysis for them, and various PhD candidates in other states even analyzing our data to understand the effects of the devastating wildfires or the benefits of wetlands, for example. I even used this data when I was a student at UHMC before I got the honor of working here. So it is such a gift to have this data publicly available for anyone to use. So things you can do: don't give up hope. No task is too big when done together by all. You can donate. Our team is determined to figure out Maui's ocean chemistry story and find solutions. And so your donation truly matters to us. We lost our West Maui lab in the Lahaina fires, and we are still looking and needing a new lab space in West Maui, or like a container lab could also do. We're thinking like a kitchen area with a sink and electric hookup would do for us for a wet lab, or a container that we could that has water and electric hookup that we can transform and park somewhere and use as a lab. We also want to extend our monitoring efforts to the North Shore and the East Side. And you can adopt a site. It costs $6,500 per site per year to do the work that we do. And you can find that option on our website to donate. You can also find our application to become a volunteer on our website as well, huiokawaiʻola.com. We are looking for a couple new volunteers to help us with our Kamaʻole team and our North Kīhei team. And you can also email us at huiokawaiʻola@gmail.com as another way to reach out and see about volunteering and joining our team. And you can also really help us by helping to share our data and our report with decision makers and policy makers. That really matters to us. And of course, you can follow us on Instagram. That's our new thing, at huiokawaiʻola. And that's everything. So mahalo nui loa. I'm so grateful for you all for staying till the end. That was a lot of data to share. But again, we're going to be joined by Dr. Kim Felinsky and Tova Callender from our team to help us with your questions. And yeah, back to you, Sarah. Mahalo.
Thank you, Liz. It was a lot, but that was amazing. I know it's hard to like condense like so much time. It's like 2 years, right? 2 years worth of data into an hour presentation. It's challenging. You did a wonderful job. Thank you. We are a little bit over time, and we have had some questions come in, which I'll go ahead if you have a question, submit it now so that we can get Tova and Liz and Kim's eyes on it. I'm going to quickly read through the ones that have already been answered while you were giving your presentation. There was just a quick question about what's the NTU, I believe, for turbidity at McKenna State Park, and that is 0.50, the NTU geomean, which you did a wonderful job of explaining. There was a question about what do you think is possibly driving the turbidity that you're seeing at Ukumehame? And I'm condensing this. Ukumehame would be expected to be a little bit higher in turbidity because of the turbulence of the surf break that's not too far away. But with that said, the extra turbulence from the hardening of the coastline, the coastal erosion that is eating into the beach, combined with the highest sediment loads coming from Papalawa and Manawai Pueo streams create the turbidity problem. And there was some hope there. Plans to address the coastal erosion from the uplands are underway. And that was Dr. Kim Polensky. Thanks, Kim, for answering that. A mahalo to DAR and DNLR for facilitating the hui getting in so quickly. And then we have one other question, which Tova is diligently in the middle of answering. But the question is, do we have any ideas of the cause of the increases in turbidity off of North Kīhei in the recent past year? So Tova's diligently typing. I don't know if Kim or Liz, you might have any thoughts of your own on that question. Oh, and she answered it.
Yeah, I mean, is there another question you want to go to?
Oh, no. It seems
Yeah,
like it. Go ahead.
So North Kīhei, there's this trifecta of the droughts, the fires, and the ungulates, including axis deer, that have really just like loosened up the soil up Mauka from North Kīhei. And so North Kīhei is an area that often floods. We get rain up country and Kula, it floods, but the difference now is all that loose soil on Mauka and in the gulches. And so that loose, it's just sediment flushes in. It's so much. And that's what we're seeing in it. And then it's not leaving the area. Is there more? Kim is our science whiz. Is there more you would like to say to that, Kim?
I might be the science whiz, but Tova lives and works and is managing that place. So I think her answer is right, and you agreed with it.
Yeah, just to read it out for everybody. Tova's answer was, from what we've observed and confirmed with work from USGS, the dry land Malka has been denuded through a challenging cycle of drought, fire, and excess axis steer, just as basically what Liz said. Those are the unholy trinity of turbidity in North Kīhei, unfortunately.
And
go
the
ahead.
point that Liz made about the gulches filling up with sediment that hasn't been cleared out, that is also because of that. Then there's nowhere for the water to go. It's just accessing all those fines and bringing them out into these pulses.
That makes so much sense. Thank you. Oh, and just somebody kept sliding in saying thank you so much for all of your hard work, Hui, the collective Hui, for what you're doing. Important work, absolutely. Okay, I think we got through all of the questions. So mahalo so much, Liz, Tova, and Kim, for being with us tonight. Just like Amy mentioned, we're so appreciative of the work that you guys are doing, the detailed analysis that you're able to give us. I know it's really valuable for our community and for our audience tonight. And like Liz mentioned, the Hui has been doing all of this work even after losing their lab space, and so they are looking for another space to hopefully be a little bit more permanent. If you know of anything, guys, please email huiokawaiola@gmail.com. All they're looking for is the size and functionality of a small kitchen, like a sink running water, and a container with or a container with like electric hookups. So again, please feel free to reach out if you guys are able to help with any of that. Our next talk will feature Courtney Klepik of Stanford University and Super Reef. So that will be in September. Courtney was just here, actually. I got to chat with her a little bit in Maui. She was working at Makni with our program director, Jill Wirt. Shout out to Jill. And so she'll be sharing the work that she does with Super Reef. So like I mentioned, our monthly newsletter always has the registration and details. So if you're not signed up for it, make sure you are. And if you are, just keep an eye out for that. And again, we want to invite you guys to come hang out with us tomorrow. We don't only live in Zoom land, we are real people. So please feel free to swing by Ocean Vodka tomorrow between 4 and 7, and know that any food or drink that you purchase will go to help furthering this work, help to continue talks like this. And we just love to talk story. Oh, here, I brought this in while Liz was, this is the koozie. You can't see my cup because it's white and my background's blocking it out. But we'll have some of these bad boys on hand for y'all if you decide to stop by our table tomorrow night. Bring your family and your friends. We'd love to see you guys. And a recording of tonight's talk will be sent out via email. So just another reason to get on our mailing list if you're interested. Of course, you can always find it on our social channels. And last but not least, mahalo to our supporters and to our sponsors. Just generous people in the community really believing in the value of work for reefs, work for clean ocean water. And we want to give a special mahalo tonight to Maui Skydiving. They're the newest local biz to come into the fold. So mahalo to Matthew St. Louis and Maui Skydiving for joining us in this important work. And that's all that we have for you guys tonight. Thank you so much for staying a few minutes over. Please have a wonderful night. And we hope we see you guys next month, but also come out tomorrow so that I'm not lonely at the table. Okay, guys? Thank you so much. We'll see you guys all next month. Mahalo Tova, Liz, and Kim, everyone. Take care and have a good night.